Hello. In this video, I'm going to explain problem 9 from the 2014 F equals MA contest. In this problem, we are told that a 5 kilogram object undergoes a time-varying force as shown in the graph. We're given the velocity at t equals 0 seconds, which is 1 meter per second, and we're asked to find the velocity of the object at 7 seconds. So, the general principle that we need to use here is that the area under a force-time graph, force versus time graph, is the change in momentum. In general, we know that the change in velocity is equal to the acceleration times the change in time for a constant acceleration. And that tells us that A is delta V over delta T. Multiplying both sides by mass, we get MA is M delta V over delta T, and so we get F is delta P over delta T. And now when you change this to a situation of a changing, or a situation in which the acceleration isn't just constant, then in general this becomes F equals dp dt, and that F will be, or that delta P will be the integral of F dt from some initial time to the final time. Now, if you don't know calculus, then don't worry about that, because really what you need to know is that the area under the graph is a change in momentum. And you can see that just by the fact that this is true. This is from what I wrote over here, that you can see that this is true for a constant force. However, if you split up this time interval into many smaller time intervals, you can say that on each interval, this statement is roughly true, and as you divide up the time into smaller and smaller slices, this becomes more and more accurate. And this is the idea of integration anyway. So all we need to do is find the area under this graph, and then make some slight adjustments, and then we'll be done. So what is the area? So really what we want is this. So I'm going to split it up into 3 regions that are easy to handle. This triangle, this rectangle, and this. There are 2 triangles and a rectangle. So here this triangle has a base of 3. So everything is in SI units. So I know that everything will be in Newton seconds, and a Newton is kilogram meter per second squared. So I know everything is going to be in kilogram meters per second. So we have a base of 3 and a height of 3. So this triangle is going to have area 9 over 2, or let me write 4.5. That will probably be easier to work in decimal. This triangle right here has base 4 seconds and height 2 newtons. So the area is going to be 1/2 times 4 times 2, which is 4. And finally, this rectangle has a height of 1 newton and a base length of 4 seconds, and so we're going to get 4 kilogram meters per second squared. And thus, the change in momentum is just the sum of all of these. So 4.5 plus 4 plus 4 is 12.5. Seconds squared, sorry. So what is the change in velocity? Well, that's just delta P divided by the mass. The mass is 5 kilograms. So 12.5 divided by 5 is 2.5 meters per second. And we're told that the initial velocity is 1 meter per second. And so VI is 1 meter per second. And so the final velocity is just 1 plus 2.5, and that's 3.5 meters per second. And so that tells us that option C, 3.50 meters per second, is the correct answer. All right. Thank you for watching, and I hope that was helpful.